Hi, I'm Andy Howard, an applications engineer with Keysight PathWave Design Software, ADS. In this brief video, I'm going to show how to use ADS to generate multi-tone signals and use them to simulate noise-power ratio. Noise-power ratio is a measure of distortion. This is the output spectrum from a nonlinear behavioral amplifier model after injecting a 4096-tone signal with a 32-tone notch in the middle. I've used Monte Carlo simulation to randomize the phases of the input tones, then I've averaged the results together. This shows the spectrum from one trial, and this shows the spectra from 10 trials. Noise-power ratio is the ratio of the power of the tones in the notch to the power in the tones in the same bandwidth outside the notch. The lower the noise-power ratio, the smaller the distortion due to the nonlinear amplifier. By sweeping the available source power, we obtain NPR, gain, and gain compression versus power. Because it is easier to understand a simpler case, this is the setup for simulating 6 tones, followed by a 4-tone notch, followed by 6 more tones. You specify the center frequency, fund 1, the frequency spacing, F spacing, the limits for the source power sweep, and the number of Monte Carlo trials. The simulation runs quickly because the amplifier is a behavioral model. More complex designs would take longer. This shows the simulated output spectrum and other data. This shows the spectrum and corresponding envelope magnitude versus time for one Monte Carlo trial. It indicates why we need to average together multiple Monte Carlo simulation results. The example includes schematics for simulating many different multitone signals and corresponding data displays for computing noise-power ratio.